For Unit 5, Day 2, we look at this diagram, and it's an isosceles triangle. It says the two congruent sides are called legs. So here and here is our legs of our triangle. The angle where the sides intersect is called the vertex angle. So angle 1 here is your vertex angle. The side opposite the vertex angle is the base. So this down here is your base. And then these right here are your base angles. And those are congruent. Okay, so these are your legs. This is your vertex. And your base, and then your base angles. Okay? So here we have the isosceles triangle theorem. And now we're basing it off this picture. If two sides of a triangle are congruent. So if AB is congruent to BC, then the angles opposite those sides are also congruent. So if I look at angle or side AB, the opposite angle is angle 3, okay, which is angle C. And then this one, BC, the opposite angle is angle A. It's saying that angle A is congruent to angle C then, which is true. Okay. Now the converse of the isosceles triangle theorem is when you flip the then and the if. Okay, so then it's then first, then the if. So if two angles of a triangle are congruent, so if angle A is congruent to angle C, then segment AB is congruent to BC. Okay? So, the first set of problems that we're going to do for this day of notes is all about isosceles triangles. In the title, you can see there's also equilateral triangles, and that will come a little bit later. So, first and foremost, example 1. Using algebra to find angle measures in an isosceles triangle. Can you find angle J and angle K? Yes, absolutely. So, we have this isosceles triangle. These are your base angles. So they are exactly the same. So angle J is 68 degrees. Angle K, I would have to add up the 68s together. So 68 plus 68. And this gives me 136. If I subtract that from 180, we get that the angle K is 44 degrees. Alright, part B. We are given that this is an isosceles triangle. We see that the legs here are congruent. So we know that these two base angles are also congruent. So, I would do 180 minus 106. This gives me 74 degrees. I know that the two angles add up to 74. But to get each angle, I have to divide by 2 because they're the exact same. So this means that both of my angles are 37 degrees if I divide 74 by 2. Okay, letter C. Can you find the measure of angle X and angle Y? So let's do this first. So we have this supplementary angles right here, here and here. So 180 minus 110 gives me 70. Okay, that's 70. I also know that X is 70 because if these two legs are congruent, then these base angles are also congruent. So this is 70. Okay, now I could do 70 plus 70, which is 140. Subtract the 140 from 180 to get the Y. And so that Y is 40 degrees. Okay. Lastly, for this page, we have letter D. Okay, this 54 I think is kind of misleading. The 54 goes to angle A. Okay, if AB and BC are your legs that are congruent, then angle A and angle C are also congruent. So this is 54 as well. Now, we also see that these little symbols right here mean that these angles are congruent. So I would say add up your two 54s. Like, here's what you're going to do. You're going to ignore this segment for a minute. We're going to look at the big triangle, not the two individual triangles, the big triangle. So we add them up, we get 108. We subtract that from 180. And that gives us 72. We know that this entire angle right here is 72. But now, looking just for x, I want half of 72, which is 36. Okay, and I know to take half or divide by 2 because I have those little marks right there, those angle marks showing that those two angles are congruent or the same. So if I divide 72 in half, I get 36 here, 36 here. Works out pretty nicely. Okay, then the last example for that section, letter E. And letter E, you have to draw an image of this triangle. So, what I would do is go ahead and draw a base. Okay, I would say the middle of that is about right here. And so this is, I know it's a sketch, but I say it looks pretty close to an isosceles triangle. So it says, in triangle RST, ST and RT are congruent. So first of all, this shows me how to label it. If ST and RT are congruent, then the T has to be up here at my vertex angle. Okay? Angle S and angle R, we know are congruent angles. They're the base angles. And it says if angle R is 9x plus 2, angle S is 13x minus 18, and angle T is 17x plus 1, can you find x and the measure of each angle? Absolutely, there are two ways to go about doing this. One, I can add all of the angles and equal that to 180. I also know that these are equal to each other, these angles. I could just simply set this equal to each other to get x. So 13x minus 18 equals 9x plus 2. If I subtract 9, I get 4x. And if I add 18, I get 20. So x is 5. Okay, so now, once I know angle R, I know angle S. So let's do angle R. 9x, so 9 times 5 plus 2, which is 45 plus 2, and that's 47 degrees. Angle S should be the exact same amount, 47. So angle S, 13 times 5, which is 65, minus 18 is indeed 47. Okay, now angle T. I can add these together, 47 plus 47, and subtract from 180. I also could just plug the 5 in. So 17 times 5 plus 1 is 85 plus 1, which is 86. Add the three angles together. Check. Do you get back to 180? You do. You should be good for this problem then. Okay? Alright, in example 2, we still have the idea of the isosceles triangles, but now we're going to talk about the side lengths and the angle measurements. So we're going to mix in kind of both different concepts, the sides and the angles. So using algebra to find angle and or length measures in an isosceles triangle. For letter A, find x and y. So I know it's isosceles for two reasons. One, the heading talks about how these are isosceles. 2, I see that these two angles are exactly the same. So these are my base angles, which means that these are congruent. So y has to be 7. Okay? Then, if I want to find x, I'm going to use the fact that I have to add up the 44s and then subtract that from 180. So 44 plus 44 is 88. And if I subtract that from 180, we would get 92 degrees. Please note, I put 92 degrees on the 92 because it's your angle measurement. 7 doesn't have a measurement, so really it's just like units. Okay, part B. We are finding x, and it looks like within the side lengths. So I know that these two are legs that are congruent because these are my base angles. 7 is just extra information that I don't need. I'm just going to set this 2x minus 1 equal to the x plus 4. Subtract the x, I get x. Add the 1, we get 5. So this would be x is 5. And I don't put feet because x is part of the expression. If I were to put feet, I'd have to plug the 5 back in and get like, oh, 5 plus 4 is 9 feet, or 2 times 5 is 10, minus 1 is 9 feet. So we know that those are congruent. They're both 9, but you could label them feet if you plugged it back in. Okay. Letter C. Again, these are going to be congruent legs here because our base angles are equal. So I would set this equal to each other. Okay, so if I was solving this, I would subtract my 15 first and get 8x. Add the 17 and get 24. And if I divide by 8, we get 3. Okay, for letter D, we have our base angles. They're both the same, so these legs are congruent. So again, set up our equation. 9x minus 73 equals 3x plus 23. And then I would solve that. Add 73, we get 96. And if we divide by 6, we get 16. All right.